Bit by bit, the human genome is giving up its secrets. If we can find out what our genes do, then we could put that information to work to create the perfect child.
A man and a woman that want to have a child will walk into a fertility clinic, and the doctors will take 100 to 200 eggs out of the woman. They'll be fertilized with the man's sperm, and then they'll do a genetic profile on all 200 embryos and choose the embryo that has the combination of genes from the two parents that the parents want to see in their child. That's where they'll start.
But as we learn more about our genes, there's a chance that some parents will go beyond choosing embryos for health and select them for more trivial reasons.
I have no doubt that in the future, people are going to want to use this technology for uses that go beyond medicine, for uses that are cosmetic, for things like eye color and height, and other things that are on the border of medicine like longevity. I have no question in my mind this technology is going to be used to provide people with these kinds of genetic choices in their children.
Even if some parents and their doctors were willing to use PGD to make designer children, the technique is limited in a crucial way. PGD can only select an embryo with genes inherited from the parents.
None of these embryos have genes the parents themselves don't have. And so if the parents want their children to be very tall or to have a particular talent that's not present in their heritage, then they're not going to be able to get it just by choosing among their embryos, but they will be able to get it by adding genes into the embryos.
One day, parents may be able to pick any gene they desire from a range of bottled genes and have it put into their embryos. It's strictly against the law to do this in humans, and yet scientists have been quietly perfecting the art of adding genes into embryos for years. In animals.
The very first gene that was added to an embryo was a gene coding for growth hormone. It's a gene that causes an animal to grow larger. And a growth hormone gene from a rat was placed into a mouse embryo. And when the mouse was born and it grew up, it grew to twice the size of a normal mouse. This had a horrifying, incredible effect on society at large. I mean, this was the first instance of genetic engineering actually occurring in an animal.
This is how they made the super mice. Thousands of growth hormone genes from rats were injected directly into fertilized mouse eggs. As the eggs divided, this new gene was copied into every single cell of the developing pup, including its egg or sperm cells, the so-called germ cells. The offspring of these mice would also be giants, their genetic blueprint changed forever. But scientists knew genes could never be put into human embryos this way. The risks are far too great.
The process is very inefficient, and so perhaps 1 out of 100 mice will be born with the appropriate genetic engineering occurring. And so I can breed 100 mice, take the 1 mouse out of 100 that has the correct gene change, and get rid of the other 99 mice. You can't do that with human babies. And so as long as the efficiency was so poor, it wasn't conceivable to do this with humans.
Compared to normal chromosomes seen here in blue, the artificial chromosome was tiny. A speck of pink amongst the blue giants. So far, it's only been designed to carry a single gene, but in principle, an artificial chromosome carrying any number of genes could be built.
With the creation of an artificial chromosome in the laboratory, we can create a brand new chromosome which has hundreds of new genes, and then we can take that entire chromosome, put it back into the embryo whole, and it gives us much, much greater capacity to modify the genome.
One day, it might even be possible to buy artificial chromosomes off the shelf. A chromosome with all the genes for perfect physique, another one designed for long life. Some even think a chromosome for added intelligence could be possible. But before we put an artificial chromosome like that into children, it would have to be tested in animals, perhaps on chimpanzees.
Because chimpanzees share 99% of their DNA with human beings, they're essentially identical to us. We can test the safety of the human artificial chromosome by placing it into a chimpanzee embryo, many chimpanzee embryos, and making sure that the chimpanzee babies that are born don't have any birth defects. If we're trying to increase the intelligence with this artificial chromosome, we actually might end up with a chimpanzee that has human or greater than human intelligence.
As a byproduct of designing babies, we could end up facing a truly terrifying situation. Chimps with human traits.
The problem is that once we tinker with the genes in the sperm and the egg, we give somebody the ability to be able to pass on these new genetic elements that have never been present in human beings before, and they get passed on to the generation, next generation. They can get passed on to generation after generation for untold number of generations. And so, in a sense, it gives us the ability to completely change the human species. There are no guarantees for parents that they will get a child out who's going to be happy and successful. What you can give with this technology is increased probability. But if we look at what parents are willing to do for an increased chance of happiness and success, it is phenomenal. Parents will spend $100,000 over a 4-year period to send their children to Princeton University. And if people are willing to spend $100,000 to send their kid to Princeton, they're going to be willing to spend $20,000 to give their children an increased chance of success in life at the genetic level.
And here's the final irony. The expense of genetic engineering means that only the rich could buy disease-free super babies. Class differences between the rich and poor would become genetic differences. Some think that eventually humans could even split into 2 different breeds.
The problem with this technology is that it will disadvantage every child whose parents are unable to afford it. And so the bottom part of society is going to be the place where all of these disease genes lay out. And the top part of society is going to get rid of them. And then the question is, will our government, will our society, which is controlled by the richest people in society, care about these diseases which are just floating around the lower class?
Whether we like it or not, genetic engineering is advancing with every year that passes. The technology that may finally put us in the driving seat of evolution is now falling into place.
The question isn't whether we'll be able to do it. The question is, what genes are we going to change? How are we going to use this technology? How are we going to try to engineer people?
The more powerful the technology is, and its proponents tell us it's very powerful, the more likely that the screw-ups are going to be very, very serious.
The only thing that's going to protect our society from the power of genetic engineering is public awareness and the public basically drawing the lines and saying, we'll go this far, but no further.
In a society based on market principles, I don't think there's any way to stop the use of this technology by those who have money.